Right. Stop, sir.
Good morning, ladies and gentlemen, distinguished guests, and our speakers. On behalf of Electronics Era, I warmly welcome you to Semicon Spark Summit 2026, themed Powering Tomorrow Sustainability in the Semiconductor Industry, organized by Electronics Era and powered by TechZone Print Media. Today's discussion focuses on how India can lead the global semiconductor ecosystem while embedding sustainability at the core of manufacturing, innovation, and policy. Over the next 2.5 hours, we will hear from the distinguished industry leaders, policymakers, sustainability champions, and technology innovators who are shaping the future of carbon neutral electronics. Now we are starting our session with the very first keynote session focusing on sustainability as a strategic differentiator. Please join me in welcoming Mr. Eduardo Oteri, Head of Sustainability Program, Asia Pacific excluding China, ST Microelectronics. Mr. Oteri will share global perspective on building carbon neutral semiconductor manufacturing and how India can align with global ESG benchmarks. Over to you, Mr. Oteri.
Good morning. We are here today because we understand the importance of saving resources for designing and manufacturing electronic solutions. But it's of paramount to build up a decarbonization strategy that also includes the emission reduction in the use phase. So welcome, dear guest. I am with ST Microelectronics. My name is Eduardo Oteri, and today I'm going to explain you why building up a decarbonization strategy makes sense. India as a country, as a market, and a community of people deserve our attention for what sustainability can contribute. For example, India is the third country in the world for installed capacity of renewable electricity so far. We have seen a growing demand for sustainable mobility solutions and alternative source of energies. So ST initiative in India are aligned with local governments and national government directives. So we want to provide you with advanced energy technology, brings initiative of circular economy and waste reduction, bringing also technology innovation in your R&Ds, and also provide you with a full compliance to overseas market like the European markets and the US markets. ST sustainability journey started more than 30 years ago. Many things happen, and actually many new things are now happening. Please focus on 3 key milestones. In 2020, ST Microelectronics has announced to reach the full carbon neutrality in 2027, means next year. In 2011, we have launched our product stewardship program called Sustainable Technology. And in the early 2000s, precisely in 2005, we were founders and member of the Responsible Business Alliance, RBA. ST Microelectronics decarbonization strategy is based on reaching carbon neutrality in 2027. This is a full compliance with the most severe scenario recognized by SBTi. So the carbon neutrality in 2027 of ST Microelectronics consists of full direct and indirect emissions, scope 1 and 2, and the 3 major categories of scope 3. From 2027, we reach and keep using 100% of renewable electricity for running our operation. And we are constantly seeking for collaborative programs with partner stakeholders to build up an ecosystem. If you look at the critical timeline, you will see that ST Microelectronics as an IDM company will reach carbon neutrality very soon. Other companies will be carbon neutral after a few years or a few decades. This is, of course, has an implication at the corporate level, carbon footprint, but also is influencing individual commercial product carbon footprint. People in ST, India, and anywhere in the world are so passionate with innovation, technology, and sustainability. This is the reason why ST Microelectronics has been recognized as one of the top 100 global innovators and one of the top most sustainable company on the planet. So at the 25th position last year and the first in electronics, hardware, and equipment industry. Let me now move on how we are capable to reduce the impact of our operation. So if you look at this chart, you can see from the base year 2018 until the end of December 2024, there is a sharp decline in global scope 1 and scope 2 emission, while the intensity of renewable electricity is increasing. At the end of 2024, we were at 84%. So you can imagine in 2027, we will reach a point in time where the global scope 1 and scope 2 emission will be low enough so that the 100% of renewable electricity adoption will neutralize the remaining emissions. As one of the goals set by SBTi, we had to reduce by 50% global emission in 2025. And actually, we have already achieved this goal at the end of 2024. you see that from 2018 to 2024, we have already reduced by 51% Scope 1 and Scope 2 emissions. Sourcing 100% of renewable electricity and steam means that we have signed long-term power purchasing agreements, so kind of a physical contract that has been signed in Italy, France, but also in Malaysia, that will last from 10, 15, 21 years. So you can understand that be carbon neutral in 2027 is not the finish line of our decarbonization strategy, it's just the primary goal to be carbon neutral. And interestingly, for example, the overproduction of renewable electricity by solar panels installed in Malaysia is also helping Singapore site of ST, because by contract, the generation of electricity and the delivery to the destination, means to ST or manufacturing sites, is guaranteed by contract. So the overproduction in Malaysia is actually channeled and sent to Amonkyo in Singapore. For the remaining emission related to the supply chain, so the Scope 3 upstream emission, we have set additional 2 ambitious goals to lower by 10% in 2030 and by 20% in 2035 compared to the new baseline that is year 2024. This will happen because ST will work together with own suppliers, identify the high emitting spot in the supply chain, introducing new technology, new framework, helping suppliers to go low and low in the emissions so that ST as a corporation will reduce remaining Scope 3 upstream emission. But decarbonization is not only about the greenhouse gases emission, it is obviously about water, circular economy, and biodiversity. In terms of water, at the end of 2024, we were recycling around 55%, and we set a goal for the future to reuse and recycle not less than 60% in 2035. In terms of circular economy, in 2024, we divert from disposal 97% of our waste, so it means that only 0 to 10% to 3% went to landfill. The future goal, regardless, we will increase or decrease the manufacturing volume, will be not less than 95% of recycle rate for our waste. And one additional and important topic is about biodiversity, not often mentioned by other companies. So we want to be sure that all the action that we are taking in our sites are not harmful for surrounding area in terms of life species and biosphere. So we set 10 selected criteria from water to soil to flora diversity. As explained before, ST was one of the founders and still is a full member, a board member of the Responsible Business Alliance, RBA. Sustainability in India, but anywhere, is made by humans for humans. This is important because being a member of the RBA is not only about sourcing mineral responsibly, but also is about the labor rights and human rights. And also we are constantly monitoring our supply chain to avoid mismanagement of any kind. Now, please let me go in deep in how we are engineering low carbon footprint products and how we can enable your solution to save resources in manufacturing and in the use phase. ST launched the Sustainable Technology Program, the Product Stewardship Program, in 2011. In 2024, we have created our internal product carbon footprint management system. And in early 2025, the systematic approach on how ST design and manufacture electronic devices and assess the life cycle assessment has been certified in compliance with the international standard 14067. And ST is the only company so far has been certified for own LCA. Semiconductor in ST are normally called as a responsible product. They are responsible because they brings a responsible feature that are aligned both to the applicable United Nations Sustainable Development Goals, but also to the European Corporate Social Responsibility Disclosure, CSRDs. Let me please spend a few words to explain you what those responsible feature means. So semiconductor that has been designed to enhance the power efficiency, so lower the losses in power conversion. They came with a manufacturing commitment or longevity commitment from 7 to 10, 15, 20 years, means that the part number will last on the market for not less than 7 years, so they can enable the Green Deal, the right to repair, the possibility for the end customer to build up and keep up inventory of original spare parts. Semiconductors that are manufactured without containing chemical substances of very high concern. Few finished goods, few part numbers that are ready, for example, manufactured in France or in Italy, where the renewable intensity adoption and in conjunction with CO2-free energy like nuclear power, that obviously is not renewable but is running at virtually zero CO2, they are offered with the low or very low carbon footprint for each unit of production compared to the average in the market. But what is really interesting is that semiconductors from ST are enabling human welfare application and planet-friendly application. The human welfare application are kind of solution where the ST semiconductor is monitoring and protecting the human life or the human health, but also is safeguarding brand integrity or IPs or data transaction. The planet-friendly application are instead kind of application where the semiconductor of ST has the potential to reduce own self-emission, but giving a substantial contribution in reducing the overall system emission. For example, heavy-duty industrial application, but also automotive application like the traction inverter or the air conditioning or home appliances. The life cycle assessment in ST is a top-down approach. So we are constantly collecting over the year, every year, data, real data flow coming from our manufacturing site, starting from raw material until the delivery to the nearest ST warehouse. So achieving a cradle to gate LCA. Upon request for few specific part number or application, key customer have requested ST also to extend the LCA from cradle to grave, also including the use phase at the end of life. Of course, for these specific exercises, we have asked the customer to explain which is the typical use phase and how they think they will reuse, recycle, anyway, they will treat at the end of life the electronic boards. Upon request, each of you can get a product carbon footprint report from ST. So please keep in touch with our sales channel or distribution channel. The product carbon footprint report is presenting the equivalent kilogram of CO2 generated for manufacturing a single unit of production of a specific commercial product. And now, please, let me provide you with a few interesting real business example. This is an example of an ultra low power microcontroller, STM32U3. This specific part numbers has been designed for offering greater efficiency and protect data in cost-sensitive industrial, medical, and consumer solutions. This specific part number brings all the responsible feature. And you can see on the right side of this slide, the breakdown of the product carbon footprint for each unit of production. So as you can see, manufacturing front end, back end is dominant, so make totally sense, intensify the renewable electricity adoption, increasing water recycling and reducing the waste generation coming from manufacturing in order to offer you with semiconductors that are going lower and lower in the product carbon footprint. Additionally, STM32 category of product counts more than 4,000 different part numbers, microcontroller semiconductor products that have been designed to address any possible combination of your use phase, but also to offering the best compromise in terms of responsible feature, lowering the impact on the environment. Interestingly, we have compared our STM32U3 versus the equivalent part number made by one of our peers. In order to do that, we have used a market standard benchmark called COMAC, that is a firmware, a commercial firmware, a standard firmware that is used for benchmarking MCU, NPU, GPUs, has been loaded and executed from the flash memory of STM32U3 and the counterpart made by one of our competitors. We have also introduced the activity factors, that is a percentage over the execution time, representing for how many hours, for how many days the microcontroller is executing the COMAC firmware. And we have calculated, and we have also measured from a dynamic current consumption standpoint, or if you prefer, from a dynamic power dissipation point of view, the equivalent generated emission from low speed mode up to high speed mode. What is really remarkable is that in high speed mode, we have seen 6 times, so please pay attention, it's not a 6%, it's a 6 times less emission compared to the counterpart. But when we go in a low speed mode, up to 20 times less emission of STM32U3 compared to the equivalent part number made by another vendor. So we have also compared STM32U3 in typical use phase, so in typical application, industrial, smart metering, and consumer wearable application. And we have seen that if we compare STM32 in the at the application level versus the counterpart versus the competitor, we have registered from 2.5 times up to 5 times higher power consumption. And again, comparing the COMAC score per milliwatt of dissipated dynamic power, we have seen that there is still a not negligible gap between STM32U3 and the industry lowest performer. So companies are normally talking and reporting emission by scope 1, 2, and 3 because they are part of the greenhouse gases protocol. But one of the concepts that is still not within the greenhouse gases protocol, but is getting more high importance, is about the scope 4, the avoided emission. So producing a single unit of production implies few milligrams or few hundreds of milligrams of emissions in terms of microcontroller. But in the real application, ST products have enabled saving of tons, thousands of kilograms of CO2. That is more than the emission from manufacturing them. Additionally, and this is really a hot topic in India, we avoid using single-use plastic, and we have also redesigned our container and boxes on how STM32 products and evaluation kits are delivered to you. And this has been done anywhere, and thanks to this new approach, we have saved around 50 tons per year of plastic. Now, let me please telling you more about how to design more environmental friendly and smarter application. Let me please spend a few words about our commitment and also our roadmap in a silicon carbide. So the ecosystem of ST is not only about our sites, but is also a deep collaboration with the Italian universities and also the National Research Council Institute in Italy. We have started our silicon carbide technology in late 1996 with several new generation and improvements. So you can see this a constant long-term ambition and investment on silicon carbide technology deployment. And talking about the silicon carbide, this is a good example of a silicon carbide MOSFET mounted inside a electrical vehicle traction inverter. So the use phase scenarios chosen is representative of the traction inverter of this vehicle. On the right side of this chart, you can see the manufacturing footprint with indicators on climate change. These represent a complete LCA, a complete life cycle assessment. On the left side, instead, you can see the use phase, so the handprint. Within a EV traction inverter, the majority of emission are generated during the use phase for the reason that the traction inverter and the onboard charger are normally designed with a lifetime of 25,000 hours or 300,000 kilometers of mileage. And during this period, during their own lifetime, they are always energized, transferring energy from tank to the wheel, from the battery to the wheel, or recovering energy by motion and recharging the battery. This is the reason why manufacturing silicon carbide MOSFET with the lowest impact on the environment and the best resource usage make totally sense. But we need also to provide you with a product that can enhance the power conversion in the use phase, because even only 1% of better efficiency has a huge impact in lifetime greenhouse gases emission during the use phase of electrical car. Now let's move to a different product. This is a MEMS sensors mounted in smartwatches, like a wearable design. You see here the use phase scenario is pretty much different, and there are no high power management concern in these use phases, and the manufacturing footprint is more dominant than the handprint, the use phases. Actually, because wearable are normally detecting the human activity while we are walking, lay down, stand up, running, etc., etc. And this is instead a good example of a time-of-flight sensors normally mounted on the front lid of your desktop computer or your laptop computer. You see here the use phase is around 45%. So it is very well balanced between the footprint for manufacturing, the handprint from the usage. And this particular time-of-flight sensor is enabling, is detecting the human presence, the human vision, and also enabling the walk-away lock. So if you are in front of your PC, but actually not looking at the screen will be dim low, eventually turn off. This can extend the battery life, but also saving electricity if it's connected, plugged to the battery charger. We have presented one of our workable solution, is a motor control solution in the Electronica India last year in Bangalore. In this board, we have achieved an outstanding reduction, the overall product carbon footprint in terms of copper metal consumption saving, water and electricity reduction for designing and manufacturing this PCB. This solution is actually a hot one because it's a real evidence, a good evidence that what we have in mind can be materialized and can be your solution. In addition to this, we have updated our e-design suite that is a open, license-free, web-based tools for any of you to start designing a new circuit, pick up components, parts from ST portfolio, selecting also responsible feature, starting simulating and build up your bill of material around ST Semiconductor to achieve an application, a solution capable of reducing the emission in the use phase. Well, ST Microelectronics has been recognized by external entity as a leader in sustainability for our commitment, but especially for our achievement. It's a 30 years business strategy, but in sustainability, the new leadership is a partnership. It's about collaboration. So ST wants to collaborate, to work with all of you. Where others see only semiconductor, we see responsible solutions. ST people see your responsible solution. So thank you so much for your attention today.
Thank you, Mr. Oteri, for the insightful video presentation to convey us with your thoughts and wonderful work done by the ST in this regard. We have received a few thoughtful questions from our esteemed attendees that we would like to direct to you. So, the question number 1 is ST has committed to achieving carbon neutrality by 2027. From a technical perspective, what are the most challenging aspects of reducing Scope 1, Scope 2, and Scope 3 emissions within the semiconductor operations?
Okay, thank you for this question that actually is very insightful. So there are, of course, plenty of challenging. So let me list up probably the most difficult that we have faced and that we have overcome. So in terms of Scope 1 direct emission, for example, achieving very high abatement efficiency requires that advanced abatement system and major investment in terms of at our site level. Also, another challenge is related to measuring and controlling fugitive emission, for example, heat transfer fluid that is complex and due to the limited standards and methodology. For Scope 2, related to the purchase electricity, switching to renewable sources require secure supply, grid integration, and also formulation of a complex power purchasing agreements. And also we need to keep in account that it's not only moving to the renewable electricity, but it's also about energy efficiency improvements that requires process optimization at any sites. We need to reduce the standby power that actually is the ones that is more wasting electricity. And also we need to advance in kind of monitoring. In terms of Scope 3, so indirect emission related to the supply chain, I believe that this is probably the most difficult among the 3 categories of greenhouse gases and scope of reporting. Is the Scope 3 requires that our supplies, a broad supply engagement and a consistent data collection, and also the accuracy of data, so the availability, quality, standardization across the value chain. So I believe that this may tell you more about how challenging is the reduction of scope of emissions.
Thank you for your response, Mr. Tori. There is also a next question. So, moving to our next question, submitted by another attendee. Question number 2. From a technical standpoint, how do ST's semiconductor solutions, such as ultra low power MCUs and wide band gap devices, contribute to sustainability outcomes in electric vehicles, renewable energy systems, and smart applications?
Okay, so here the point is about working closely to our customer, to our distribution, to understand which is the real use case, or if it's not about the use case is about emission profile. So obviously semiconductor are not all the same, and the semiconductor manufacturing company are not all the same. So you can understand those also solutions are pretty much customized. So knowing which is the typical mission profile or use phase, we can select and suggest to our customer which is the kind of wide gap power discrete, but also which is the microcontroller or the motion environmental MEMS sensor that better fit the solution. The idea to have, for example, more than 4,400 different part numbers of STM32, but a rich portfolio also of analog and power and sensor is also because there are pretty much a very broader combination of use phases, so typical use cases, and also different requirement in terms of environmental compliances. So the idea is that, and this is what we are doing, is to talk with our customer to understand how they believe their own solution will work, then suggest the best product. So in terms of electrical vehicles, I can tell you, and probably in my presentation was already mentioned, that we have a focus on traction inverters, on board charger. Those are devices within a electrical vehicle or hybrid car that are managing totally the power conversion. So the efficiency should be optimized within those domains. In terms of renewable electricity, and India is one of the most active country in the world for installed capacity of renewable electricity, silicon carbide and GaN have offered the opportunity to boost efficiency on small, medium, and large scale integration. So it means that all the infrastructure can become smaller in terms of size, but becomes more powerful than before. And for other kind of application, like for example, smart system, like smart metering for watering, and also medical machines, I believe that the combination of ultra low power products can either way saving electricity and in the use phase, but also enhancing the possibility to have data collection and use data, so the value generated by data that we are managing for helping, for example, patients in terms of medical machines, but also helping households to reduce and detect water spilling and try to optimize water resources. This is a huge and direct impact to local community in India, for example. Thank you so much.
Thank you so once again for your detailed insight. We hope these responses have addressed our audience questions clearly and effectively. With this, I would like to move on further. And now, it is now my honor to invite Mr. Abhijit Sinha to deliver the opening keynote. Mr. Sinha is a National Program Director, Ease of Doing Business, Principal Advisor, Services Export Promotion Council. He has been instrumental in strengthening India's semiconductor and manufacturing roadmap through policy innovation and ecosystem development. Sir will provide insightful experience on the topic Viksit Bharat and Modinomics 3.0, Building India Global Semicon Manufacturing Hub. Sir, the virtual stage is all yours.
Thank you, Vani. Very kind of you. I hope I'm audible to the audience and August gathering of Semicon India. My topic is to speak about what ambition India is developing under the third term of Modi Economics 3.0. This also has a vision to build India as a hub for semiconductor and electronic manufacturing. This is something which has not happened over a period of time. And I can say the history that we can recall, it has not happened in past. Semiconductors are those components which we have been importing for a long period of time. And this ambition to not only build them in India, but also create a conducive environment to manufacture and make India as a manufacturing hub for other companies to come and manufacture here is highly commendable. This ambition has a reason. This ambition has a bigger picture, bigger program, larger vision. That is where I wish to come and share my views with you. If you look at India's journey from its beginning and towards 2047, which is going to be India's 100 year, you'll be able to find an ambition, an aspiration, vision, and then working on that particular ground in different segments. When it comes to manufacturing, we are as a nation, as a matured economy, should be wise enough to choose what is good for us to do manufacturing. Just for an example, so that audience would be able to understand what I wish to bring here is India is third largest exporter of pharmaceuticals in volume. But when it comes to exporting in terms of value, we are 11th. So tomorrow, whether we should choose to manufacture a chip, a semiconductor, an artificial intelligence auxiliary GPU, or a transmitter, or a conductor, or any sort of that what we have been already building as a machinery, that is going to define the value that it adds to the economy. So I'm glad that the vision which our Prime Minister has taken, that Semicon is not something that we are only looking at manufacturing, but we are also looking at the surrounding environment which should build it. 2 points I just want to make in the opening keynote, and rest all of you have a great day where you are going to discuss multiple conversations, multiple aspects and components of this manufacturing and market. Speaker who spoke before me has given a good insight of how it is connected with environment, climate, and the materials which it is using, also making a significant amount of carbon impact, how it can be reduced. So these 2 points, which my dear listeners, audience, students, scientists, and policymakers, I wish to make, is about innovation. It is not about entrepreneurship. And if you will look at India, in last 65 years, in last 75 years, India has grown typically from, you can calculate it from the point of view of a young generation, which is now working on this. They would look at India's journey from 1947 to 2022. When we got independence, from 1947 to 65, we were cultural economy. From 65 to 85, we were industrial economy. And from 85 to 2000, we started becoming computer country, computer generation. And from 2000 to 2022, we started becoming digital and global economy. Now you are in 2026 and approaching to 2047, which is going to be 100 year of India. And on this point, what is our understanding of innovation? How are we subscribing this? This makes a lot of difference. And to make this understand, I'm only capable to give you an aspect of how innovation is defined globally. If you look at last 500 years, innovation regarding core values, like Japan is known for innovation of something, Germany is known for innovation of something else, America is known for something else. India has not been known for some significant, true core innovation in last 500 years. Why I'm saying so is the generation who has to do this innovation, the young generation who has to work with global countries and competence, we sometimes give our ammunitions and arms back while even debating that India has been able to do so. And the culture which was imposed to us was a culture against any sort of large enterprise. So someone making money, someone creating a big enterprise business of manufacturing vehicle, Mercedes, BMW, or any Samsung, Nokia, Apple, any company, any industrialist building an economy in India. In last 80 years, he was proven to be without trial a villain. Why? Is because if he has made so much of wealth, he must not have done it fairly. He is someone who's an enemy to people who are with marginal capacity, marginal income. In last few years, whatever has happened, it has created a dead culture for innovation. The second point which I wanted to make is when in institutions we are not creating people who will be able to uphold the transition of electronics and semiconductor manufacturing in India, it is again difficult for the upcoming industry to find right talent who will be able to work on it. And what goes wrong with institutions when they teach engineering or when they teach technology or innovation is that they teach about it. They tell you what is engineering, how it has happened over a period of time. They do not do engineering. When you do engineering, you need to skip or you need to complete the history reading of how engineering has happened over a period of time in a short period, and the main amount of focus that you spend should be on doing engineering. And when you do actual engineering, you definitely bring out innovations. So most of the colleges, most of the curriculum which was followed by India till 6-7 years back was only talking about engineering, teaching about it. They were not actually doing engineering. And the result, core innovation was not happening. So right from changing the mindset of people that a large businessman, maybe it's wealth of today's GOBP, Tata, Mahindra, anyone who's working JSW, Dani, I can speak n number of large industries who are now focusing on the innovation. And people who used to believe that all these large industries and industrialists are villain to the nation, that mindset is changing. Colleges and their curriculum, which was not innovation oriented, are now shifting their base, shifting their focus. With this, the last point which I want to make is why are we doing all this so and what we wish to achieve. There are two estimations that India by 2047 will reach to a $35 trillion economy. This $35 trillion economy growth to a country which is today $4.18 trillion is divided into sectors, is divided into emissions. Decarbonization to geospatialization, digitalization to electrification. There are n number of emissions which India is having in different sectors. But when it comes to total output of that emission, which we are holding into automobile, to pharma, road infrastructure, to semiconductor, artificial intelligence to culture and art, export to trade, MSME to a large corporate, they all have to zero down to a certain number. If you ask BCG, if you ask ENY, if you ask KPMG, they all have predicted somewhere around $35 trillion economy for India by 2047 when it turns 100. There is a parallel conversation which is giving us an opportunity to look into what innovation can do and what semiconductor and the conducive environment, which is a challenge for India. I have told you very clearly that what are the challenges, and I'm sure that a lot of you are going to bring the challenges of auxiliary support system operations and in development of semiconductor in India today whole day. So the challenges which are coming, if we manage to pass through them, then we build a different economy, not $35 trillion economy. Just to give an clarity to audience who are listening to me, is how this $35 trillion is calculated is by some child who has taken birth after 2020. He would be able to spend somewhere around 240,000 US dollar in his lifetime. So any student, anyone listening to me in this call, if he has taken birth, his birth date is after 2020, in his lifetime, in everything on from right his bike to his education to his health and to his house, he will spend 240,000 US dollar. And in 2047, if you multiply it with the population of India, if we go on increasing in per capita income, it would be 164 crore. If you multiply these numbers, you will get a calculation of $38 trillion economy. But this will not grow on default. This has to have indicators and boosters from different sectors. And if the sectors and the boosters act right, then you build a different economy. Why I'm going to now quote you the different economy, the other number, is because semiconductor challenge is one of those challenges which is standing between our ambition, which we are likely to complete at $35 trillion, and the ambition which I'm going to quote you now. India has doubled its economy in last 6 years. Our Minister of Commerce and Industry has categorically defined that which year it was at what stage and where it have reached. When doubling of economy happens and you calculate, it does not go to $35 trillion. It goes to $52 trillion economy. And that $52 trillion economy gives us a clarity that in last 65 years, India has created first $1 trillion economy. So if I say that I took as a country to build 1 trillion, 65 years, I took 65 years to bring 1 trillion. Next trillion is 8 years. Next 1 trillion is in 8 years. And then next 1 trillion is in 5 years. And then next 1 trillion, fourth trillion I can say, is in 3 years' time. So now if we are a $4.8 trillion economy, and on a conservative note, if I consider only the hard abating sectors, which are manufacturing, which are machineries, which are hard, heavy industries, then I may have a conservative figure of 3.89 or $3.9 trillion. In 2026 to next 6 years, if I manage to build this economy, which is today 4.18, and on conservative side, we are taking 3.9, by 2030, $6.5 trillion. And this with a lot of responsibility and sincerity, I'm saying, because in last 6 years, India has doubled its economy. So if in next 6 years, we also double it, then we will reach at around 6.5 trillion by 2032, 13 trillion by 2038, 26 trillion by 2044, and 52 trillion by 2050. My dear friends, the conversation which you are holding is holding the potential of changing this economy. What you are discussing, what challenges you are facing, what type of brain drain or what type of re traffic re branding of Indian industry need to be done so that the talent that we have lost to different countries should come back to us, and the talent which we need to grow within the country, innovation and the R&D that we need to spend and that we need to grow in our country, these all are semiconductors to the semiconductors. And I'm sure that the conversation which you all are going to do today is a very, very significant conversation. Being National Program Director of Ease of Doing Business, I understand that emerging technologies, when they are coming to a country, particularly their manufacturing, their adoption, their financing, their industrialization, their transition, everything turns out to be a very difficult task where all stakeholders, be it a policymaker, government, private companies, students, academia, scientists, each one of them, they need to come together to make sure that we are creating an environment which will give some result. And the conversation that we are going to do is a significant conversation. Organizers has promised me that whatever recommendation will come from the talk today, they will bring this conversation, this recommendation to me, and I will look into it. I'm also principal advisor to Ministry of Commerce for Services Export Promotion Council, and we are looking at a framework to build a global supply chain where Indian MSMEs should be empowered and should be capable to give supply of those components which are required with the core innovation of semiconductor, so that India altogether, not only in the manufacturing of semiconductor, would be able to become a hub for export. Thank you. Have a great day, and I look forward to the recommendation which Semicon India will bring.
Thank you, Mr. Sinha, for enlightening us with your thoughts. With this, moving forward, we now invite Mr. Vivek Mahajan, Senior Vice President at Infineon Technologies, India, to share insight on industrial infrastructure and computing applications deriving sustainable electronics innovation. Sir, we look forward to your perspective.
Thank you. Am I audible?
Yes, sir, you are.
So, give me a sec till I can share. Is the screen visible?
Yes, sir.
Give me a sec. It's a little bit. So, good morning, fellow industry leaders, as well as thanks for Electronic Zone to invite me here today. It was a very insightful thing what Mr. Sinha has shared about the development plans of India and the aspirations. And also, I thank my colleague from ST, who has very wonderfully presented on the carbon neutrality goals and how the semiconductor industry is working on the same. Now, India is on the cusp of becoming the world's third largest economy. And with that growth comes a defining question. Can we build the electronics ecosystem tomorrow without repeating the carbon mistakes of yesterday? Well, at Infineon, we believe it is definitely yes, and we will be committed to it and walking the path with India. Now, as we see that the semiconductor push by the India's electronics market, which is projected to be 500 billion by 2030, and wherein the push from the government from the India Semiconductor Mission, as well as all the production link incentives which have been launched, this is really transforming, and a huge amount of manufacturing investment is coming into it. Now, the question is whether that growth can be sustainable. India is already committed to net zero by 2070. To get there, carbon neutrality must be embedded at every level. And that is where we also play a role, not an insider, but as a committed partner. Infineon ranks amongst the top 15% of the most sustainable companies. We have been listed in the Dow Jones Sustainability Index for the 13 consecutive years. And these are not mere aspirations, they are audited results. The credibility is what we bring to every partnership. We work on two themes, decarbonization and digitalization. That means what we do inside our operations as well what we produce must support the decarbonization theme. And of course, digitalization, which is the hallmark of today's world, as well as digitalization leading to AI and the data center investments, which we need massive amounts of energy, and how these can be done in a sustainable manner. And this is very much possible to be technology leaders as well as be the pioneers in sustainability. At Infineon, 84% of our scope 1 and 2 emissions reductions have been reduced compared to 2019, and our goal is to be carbon neutral by 2030. For scope 3, we have already established the science-based targets with 94% of the suppliers. We have 100% share, and that's really 100% share for electricity, what we consume from renewable energy. And our impact from the products we deliver is about 53 times of what we as a carbon dioxide saving versus what we consume. That is really a factor of 53 times the impact on carbon. At Infineon, 32% of the water recycling rate last year, and will further improve the efficient and sustainable water consumption. 76% of waste has been recycled, and this supports the circular economy, which everyone today talks about, and which is very, very well received in the industry. 50% of our products have now come with product carbon footprint matrices, and customers can ask for these, which extend the visibility of our decarbonization efforts and demonstrating transparency down to the individual product level. So working both on the cleaner manufacturing as well as the greener impact, which I just said, within our manufacturing as well as the products we make for different industries, right from generation of renewable energy to transmission, very efficient transmission and distribution, and of course, very efficient consumption. We have reduced our direct emission, as I said, by 84%. 100% of electricity comes from renewables, and science-based targets have been installed for scope 3 emissions. So as you see, where we participate mainly in the industry and infrastructure part, whether it is solar or wind generation, and of course now upcoming hydrogen, Infineon plays a great role in how semiconductors are designed to be most efficient and enable these applications for cleaner energy generation. Transmission and distribution, as we see, for example, in HVDC, we can transmit DC, which is much more efficient at even higher and higher voltages. The new aspect of solid state transformers, energy storages on the renewable grids, all this enable very efficient use of renewable energy, transmission of renewable energy, and of course at the industry, the consumption, whether it is robotics, whether it is drives, this is all enabled with our very, very efficient power semiconductors. Whether it is silicon carbide, or gallium nitride, we have huge investments to make sure that we remain at the front of these technologies which enable all industrial infrastructure and e-mobility applications. When now we see the data center investments in India will increase drastically, the efficiency where at every stage, as we call from grid to the core, as there are many stages of power conversion, it's easier to see that the advanced semiconductor use, which will be advanced silicon carbide, as well as gallium nitride, up to 10% more efficiency can be achieved, and power density as well. Higher power densities means less material consumption, smaller data centers, less heat generated, and this all adds to the carbon saving. As said earlier, that most of the products now are coming with product carbon footprint data, granular, and it is bottom up, covering materials, manufacturing, energy, direct emissions, and transportation as well. One interesting aspect is now that India is a very large user of UPI, which is 14 billion, over 14 billion transactions per month, the world's most vibrant digital ecosystem, I must say, and our secure pay green technology enable contactless cards, which avoid plastic, that means they can be used with the greener or other forms of packaging. And I would like to say we are not merely a supplier. We are also building with many institutes. NALET, for example, we have signed MOUs, and we will be training manpower, both in the efficient use of semiconductors as well as how to build the skill for workforce for the future for the semiconductor industry. This would be our contribution to the nation building as well as the aspiring electronics and semiconductor segment in India. Thank you with this, and let's together drive decarbonization and digitalization together.
Thank you, Mr. Mahajan, for your wonderful presentation and the steps taken by Infineon Technologies for net zero carbon emission for the future of our Mother Earth. Now, moving forward with our panel discussion one, theme of which belongs to the theme of sustainable semiconductor manufacturing from hub, fab to finance. Our first panel discussion is on the topic sustainable semiconductor manufacturing from fab to finance to discuss sustainability across the semiconductor value chain from manufacturing floors to capital markets. I invite our distinguished panelists. Panelist number 1, Mr. Vivek Mahajan, Senior Vice President, Infineon Technologies, India. Second, Mr. Gurusharan Dhillo, Director, E-Mobility, Indian Energy Storage Alliance. Third panelist, Mr. Varun Bhatia, Vice President of Electronic Skills Sector Council of India. And last but not the least, Mr. Pankaj Kedia, Founder and Managing Partner, 2468 Ventures, AI Investing Advisory and Consulting. And our moderator for this session is Mr. Vishwas Das, Account Director, Seraphim Communications. This panel will explore responsible sourcing, green fabs, ESG compliance, financing and sustainability, and the evolving investor lens. Let's begin the discussion. Over to you, Mr. Vishwas.
I hope I'm audible, Vani.
Yes, sir, you are audible.
Yeah, thank you so much. And good morning to my fellow panelists. I'm delighted to be here among such an august gathering of industry leaders. I welcome to our discussion on sustainable semiconductor manufacturing from fab to finance. Today, we will explore eco-design, SIC, and GAN innovation, fab decarbonization, resilient supply chains, responsible sourcing, and financing energy-efficient chips for EV and renewables. So with this, I would like to welcome all of my distinguished fellow panelists. My first question goes to Mr. Vivek Mahajan, whom I was listening to before this presentation, before this panel discussion, and I remain glued to understand what kind of intricacies Mr. Vivek Mahajan was talking about. So, Mr. Vivek Mahajan, with your permission, I would like to go ahead. And my first question to you is, Infineon has been at the forefront of power semiconductor innovation. I wanted to understand how can technologies like SiC and GaN significantly reduce system-level energy losses in industrial and infrastructure applications. Over to you, Mr. Vivek.
So Infineon's leadership in power semiconductor innovation has indeed been instrumental in driving the development of many cutting-edge technologies, of which silicon carbide and gallium nitride are the examples. These technologies have the potential to significantly reduce system-level energy losses in industrial and infrastructure application, leading to increased efficiency, reliability, and cost saving. Now, what are the silicon carbide and gallium nitride? These are different materials. Like we use silicon for most of the devices today. These are silicon carbide and gallium nitride are wide band gap semiconductor material. And these offer several advantages over mostly used silicon power devices these days. One is very high switching frequencies. So if you take, for example, silicon carbide can operate depending on the power level as well as the voltage level. It may be able to operate in some certain tens of kilowatts to up to hundreds of kilowatts. Gallium nitride, whereas can actually switch even higher, going beyond 500 kilohertz and even going to megahertz. The second is the losses. For every, let's say, switching cycle or the conduction of the current, now silicon carbide as well as gallium nitride exhibit lower conduction and switching losses, resulting in increased efficiency. And of course, this means lower loss. That means lower heat dissipation. That means you need lesser cooling effort. In the case of higher voltage ratings, silicon carbide can handle much higher voltages, and therefore it is more suited for industrial and high power ones. Whereas for the gallium nitride, it is typically used for lower power, high switching frequency, compact power supplies and systems. Now, these are more suitable to, for example, motor drive applications. And if you know, motors are used anywhere, almost everywhere in our life, be it industry, be it at home in our inverter or in our appliances like washing machines, air conditioners. So a huge amount of motors are used in the world. And using these power semiconductors, advanced fabless semiconductors, you can save up to 50% and resulting in increased efficiency. Now, power supplies are again one great application where up to 30% less losses can be achieved if you use these advanced wide band gap semiconductors like silicon carbide and gallium nitride. Renewable energy systems, and this, for example, silicon carbide especially is enabling many new things. For example, in high power converters or high power solar inverters, you can go to even higher and higher voltages. And with higher voltages silicon carbide available, you can go for simpler topologies, which reduces the system cost, system sizes, and enhances efficiency to a much higher level. Electric vehicle charging, electric vehicle driving is another example where the battery lives can be extended, where vehicles on the same charge can run longer. And the latest and most demanding application would be, sorry, energy demanding application will be data centers. And here we will see much higher use of these wide band gap semiconductors. So silicon carbide and gallium nitride are the future of switching technology, and especially going towards energy-oriented applications.
Yes, very well summed up, Mr. Vivek. And now I would like to move on to Mr. Gursharan Dhillon. And my question for you, sir, is as India scales EV adoption, how critical is sustainable semiconductor manufacturing to ensure the EV ecosystem itself remains environmentally responsible? We have been talking a lot about environment sustainability, so I wanted to get your perspective on this. Over to you, Mr. Gursharan.
Thank you. Thank you very much, Raj. I hope I'm audible.
Yes, you are.
Thank you, first of all, to the organizers for having me. And I've been hearing the conversation since morning. And without doubt, sustainable semiconductor manufacturing will be the critical missing link as we ensure transition not only of vehicles to electric vehicles, but as we transition to clean energy. If you look at specifically the EV context, a typical electric vehicle uses more than 3,000 chips. And these chips are controlling everything to do with the interface and control aspects of the vehicle, starting from battery management systems, powertrain management to ADAS systems. But there is also a sustainability aspect to these semiconductors. For example, semiconductor manufacturing is extremely water consumption heavy. In fact, a mega fab facility can consume as much water as it is required to cater to the needs of an entire city. Very recently, there has been a study by Niti Aayog that has spoken about the water table of Delhi, and it is likely that we will run out of groundwater in the next 4 to 5 years, which means that we need to make environmentally sound decisions today. The second, of course, is the energy itself that semiconductors will consume in the manufacturing process. And I think there should be a focused approach to make sure that we integrate renewable energy into the manufacturing ecosystem. And I think the third is, of course, the circular economy. I think recycling will be very important to ensure that all the critical and rare earth minerals that we utilize in the manufacturing of semiconductors, they are recycled so that we don't keep mining for rare resources. I think those are my thoughts for now.
All right. I heard you right. So before I move on to next question to you, Mr. Gurshan, which is basically about policy and industry collaboration, I would like to move on to Mr. Varun Bhatia. This question is also related to sustainability and semiconductor manufacturing. So, Mr. Varun, I would wanted to get your perspective on sustainability in semiconductor manufacturing. Requires a highly skilled workforce. What new skill sets will be essentials in green fabs and advanced electronics manufacturing? Over to you, Mr. Bhatia.
Sure. Thank you, Vishwas, and good morning to all the panelists, industry experts, and all the people, the participants today. So it's really nice to virtually connected with you all and give my thoughts and share my views with you all. So yes, you rightly mentioned, Vishwas, as this transition is happening, and as Vivek sir and Gusharan sir also mentioned about, new way of working. So this transition, which is there in the industry, especially semiconductor and electronic manufacturing industries, just to give a little perspective, what Gusharan sir was mentioning about the usage of, the infra which is required to set up a one fab and how it can be now into a green fab. What is the need and the skill set required? I mean, tentatively, one fab requires like approximately 10 to 20 million liters of water every day, ultra pure water. I mean, that's the basic requirement. Approximately, it needs 600 to 700 megawatt of uninterrupted power supply. So having such a strong infra, which is a basic requirement, and then definitely the skill sets that would be required, to hold on these things, and the output is highly hazardous. We all know, I mean, the chemical that are used while making a chip for a fab or the packaging part as well. So the skill sets which are required at the on the manufacturing side, and more importantly, once the manufacturing is completed, the skill set which are required to recycle those things for the better environment. So first and foremost, I would like to mention the greener economy skills that are required, especially the circular economy, the ESG goals that we have. So skill sets pertaining to what new ways of renewable energy can be used to fulfill the demand for any a semiconductor manufacturing facility, to make it a greener facility, rather. That's the question is. So knowledge and the skill sets pertaining to those things. Another very important element that is required is industrial safety, because these industries are a huge setups. It's not a small one. They are highly large scale industries. So industrial safety, knowledge of electrical hazardous chemical that would be used. So definitely one should be having a skill set that which chemical have a low GWP, which gases do not affect the environmental at a higher stage. And yes, the most critical part, the chips that are being used, once they are into the market, and then if we have to roll it back for some other modifications, the recycling part of it, so that the complete value chain, once it start from sand to silica and then to the chip, and then how we recycle and roll it back. So skill sets pertaining to those elements, chemical, gases, recycling, restoring, and then making it a part of a healthy environment. Those things we also have a lot of demand and many colleges, and we are making some courses as well on these things, so that the workforce which are there at ITI diploma or engineering level, obviously the intensity will vary, but yes, we are making those skill sets as part of the curricula in consultation with industry, so that basics of electrical, HASCAM, nature friendly environmental gases, those things can be incorporated, and accordingly the industry also complement to the nature and the skilled manpower which are required. They are also parallelly aware of these things. So I think these are very, very important and basic elements which skill sets that would be required to work in these industries, Vishwas.
Thank you, Mr. Varun. You have summed up very well, and you have brought in some concepts or some issues which are very important to discuss. And I would like to move on to Mr. Pankaj Kedia ji. Sir, I wanted to ask you about, my question is basically from an investor's perspective. So my question to you is, how is ESG performance influencing capital allocation in semiconductor and deep tech startups. Over to you, Mr. Kedia.
Yeah, thank you, Vishwas. I will actually build on what Varun, Vivek, and Guru Sharan said. I was at Intel for 20 years and Qualcomm for 10 years. Then I decided to go to the dark side and become an investor. And in the semiconductor business, in the data center business, it is always a global sector. You're not going to do chips in India only for India, or data center in India only based on Indian technology. You're going to get the best technology from anywhere in the world and hopefully export it to everywhere in the world. So it is very important to adhere to some common standards, some common expectations. And Varun, as you mentioned, if I just focus on semiconductor,
Yes, sir.
power is important, energy efficiency is important. In a fab, water is important. Hazardous chemicals are important, right? And as an investor, our job is to invest in things where the risk is minimized and success, revenue, output is maximized. So I would not invest in an opportunity where ESG is an afterthought or ESG is patchwork. I would invest where ESG is very much part of the plan, where the products and technologies are ready for global usage. There's a lot of talk about AI investments in India. Last week at the AI Impact Summit, 115 billion from Reliance and 100 billion from Adani, right? These issues we are talking about are very much part of that discussion. They will use technologies from an NVIDIA. They will deliver to the Googles and Metas and Anthropics of the world in India. And so you have to meet the global standard. So Vishwas, the punchline is this is not a nice to have. This is a must have. If you don't have it, it will become increasingly difficult, if not impossible, to raise any money. If you have it, it is absolutely a differentiator. It is absolutely needed to play on the global stage. This is a priority. Anybody in the audience pursuing opportunities in this space, please make ESG part of your strategic plan.
Absolutely. I totally agree with you, Mr. Kedia, that ESG is a topic or subject which is not an afterthought. It should be well planned and it cannot be ignored. Now, I would like to move on to Mr. Vivek Mahajan. Sir, my next question is from a manufacturing standpoint. I wanted to understand from you what practical steps can fabs in India take today to move toward carbon neutral operations without compromising productivity and cost competitiveness. Over to you, Mr. Vivek Mahajan.
So I would say since the semiconductor sector is just building up in India, this is a unique opportunity that the start itself is great. There is a huge amount of knowledge created in the world on the sustainability matters in semiconductors. And it's not that India will have to struggle with the legacy system and improvise over time. All the fab build-up, the process setup, the way that things are designed, there is an accumulated knowledge, and India must capitalize on that to start really with a clean slate. And one of the most important thing, as Kedia already mentioned, that the investor community already looks at, this is not an option, but a kind of a must for the risk mitigation as well. And the regulatory framework is also tightening. So the best is that the employee awareness from the very start, that means this has to be built sustainability, carbon neutrality, being conscious and cautious of everything needs to build into the culture of the organization. And most of the people being hired are fresh graduates struggling, the institute struggling to really impart this new knowledge. I think this is a great opportunity that the industry starts itself with a clear mandate, clear opportunity that this is woven in the fabric of the company. So first thing is obviously to start with that this is built into how our fabs are set, renewable energy. For example, most of the clusters coming in Gujarat and around. So there is a huge amount of renewable energy being set up there. Energy storage systems, water. I think my predecessor already said that water is a main concern, so water should be already taken care of. The supplier base to select, as everybody talked about science-based targets, so choose those supplier bases very carefully and leverage on the knowledge already created in the world. A colleague from ST also explained, we also have enough. There are a lot of advisors and consultants who can actually guide at every step how these processes have to be set up, how the suppliers have to be audited. Yeah. So I would say there is a great opportunity that India, the time to carbon neutrality for the Indian semiconductor industry should be actually lesser than the rest of the world.
Yes, I totally agree with you, sir, that there are multiple factors which you spoke about, and I totally agree with you that Indians must capitalize on knowledge and employee awareness from the very beginning is very important. With this, I would like to move on to Mr. Gusharan Dilloji. And my question to you is what policy and industry collaborations are required to align semiconductor supply chains with India's clean mobility targets? Over to you, Mr. Dillon.
I'm sorry, I missed you for a second. Can you repeat the question, please?
Absolutely, absolutely. No worries. My question to you is what policy and industry collaborations are required to align semiconductor supply chains with India's clean mobility targets?
Okay, that's a great question because I think you picked on two themes. First is sustainability, second is policy, and I think they work very closely together. So I think with context, today policy is working mainly in terms of building up capacity. So programs like the India Semiconductor Mission I think it was last July when Prime Minister Modi was at the India Semicon Summit, which happened in Delhi, and where a lot of investments and action in the semicon space was announced. What is now happening is that this, because semiconductor as itself is a product, but it gets integrated into certain other, what do you say that, sectors. So if I speak specifically about automotive, now the localization goals that are specified under PLI schemes, they have a close linkage to the output that you will get from the semiconductor machine, which is really good because it works as a natural barometer or a natural check of the output of one scheme feeding as an input into the other. That is on the government level. I think the second level is, of course, corporate partnerships. So, I mean, if I may name a brand, Tata and Qualcomm had entered into a JV. They're focusing on semicon manufacturing, and they're trying to do this basically to feed into their own product lines and
I think
I think,
yeah. So
yeah,
I'm
I'm not
sorry,
able to
I'm
hear you.
lost for a second. I'm
Yeah.
back. Am I audible?
Yes, you are back. You are back, sir.
Yeah. So speaking about the Qualcomm and the Tata model, where they've basically built up capacity. On the government side, you have agencies like the Semiconductor Lab in Chandigarh, which is collaborating with agencies like ISRO and other OEMs to build microprocessors. So I think basically the way this ecosystem is evolving, it is evolving very strongly as a combination of policy, partnerships, and also offtake arrangements. So that I think offtake arrangements from OEM to fab, I think these are also playing a very important role in ensuring that there is a sustainable demand flow that they need to cater to, and then that helps them to synchronize their back-end supply chain and bring in more efficiency into the overall semiconductor manufacturing process.
Yeah, so I got a point. So basically, you spoke about semiconductor, the industry getting integrated into different allied sectors as well, and corporate partnership part was also well taken. So I would like to move on to uh, Mr. Varun Bhatia. And Mr. Bhatia, my question to you is like, uh, how can industry and skill councils work together to create a future-ready talent pipeline aligned with ESG and sustainable goals?
Right,
Basically, it's about the working in tandem amongst this
right,
industry. And
right.
yeah, over to you.
Yeah. So thanks, Vishwas. Again, a very, very important element in any industry, rather, because it's always a man behind the machine that we say to give the best output. When it comes to the delivery mechanism. And semiconductor, like Pankaj sir also mentioned, it's a global requirement. It's not only we are, if we produce skilled manpower today and want to become the skill capital of the world. So definitely a strong collaboration between sector scale councils and industries are required, and that's what our mandate is as well, to bridge the gap between the industry and the academia, basically the supply and the demand side. So one most important element that we do, and as a sector skill council as well, is like capturing the absolute right demand from the industry. Like this semiconductor, to give you an example, we have a dedicated expert committee group, people from different academics, industry leaders. They are part of our group, and we call them as a national occupation standard group. I mean, the we want to create those standards which are nationally accepted by group of industries, and they are global benchmarked that way. So we do an intensive discussions with them, so that firstly we can get to know what exactly are the need and the demand of the industry, Definitely, semiconductor is not an easy game, like everybody mentioned about it. And when we are setting up its base in India, the manufacturing side of it, the designing, it's still been taken care for quite long now. I mean, many engineering colleges have these skill, these courses and all. But when it comes to the manufacturing side, so one another important element that we are doing is co-creating the curriculums. Firstly, uh, uh, preparing some virtual labs, because as we know, if somebody wants to from academia directly wants to go and work in the semiconductor industry, it's like a big thing. When you work on clean rooms, big machines, wafer dicing, laser cutting, the scope of error are absolutely less than zero, because these are high end machines. So, and to have these type of a capex at any academia or at any private institute or a center of excellence, it has to be created. So some virtual labs, which again, or a simulators in association with industries. We are also setting up a one center of excellence in Bhiwadi, in one of the electronic manufacturing cluster. That's from the all the bootstrap funding of ESCCI. I would like to request all the industry leaders over here that that center of excellence that we are setting up, dedicated to electronic manufacturing and semiconductor as one of the core sectors, where we are taking the inputs from all the industry leaders, so that from very basic, like giving a knowledge to any person of in basic industrial safety, electrical safety, HAZCAM safety, so that when he goes and work in there, at least he know the basics part of it. I mean, the 5S systems when they work in, to the advanced level engineering that is required to work in the semiconductor. And yes, ESG, no doubt. I mean, we all have spoken about it. The goals, the mission of, which are required to create an environmental friendly or a green energy efficient system, industrial revolution system. So basics understanding from very basic to the advanced level in bits by bits pieces, as per the, the target audience that we are training, whether they are ITI to diploma to engineering level. So, and one another important element which SSC and industry, we feel, together can make a difference, is the joint certification programs to the candidates. Because like in, some Western countries, we have seen like, they have their own programs, but when they join hand with government, so it becomes a win-win for the candidate and for the industries both. So starting from curriculum designing to training to assessment and then certification, the complete life cycle of it. And that's what we also follow as a basic principle at our council, Electronic Sector Skill Council. So my take is a joint collaboration, a joint industry institute partnership, co-branded by Sector Skill Council and industries, so that from day one, when the candidate moves out from this academia, he's absolutely, if not 100%, but at least 70 to 80% ready to deliver to the industry, and the lead time is less and efficiency is more. So I think by these steps, we believe we can definitely create a young capacity building for the country, and they can then be absorbed and hired not only by India but by other countries as well if required, and we can definitely become an a skill capital of the world. That's what we say at MSD as a
Yeah, yeah,
as a
and I
tagline.
agree with you. Yeah, I agree with you, Mr. Varin, that we should become a skill capital of the world. I totally agree with you. So now this brings me to Mr. Pankaj Kedia. And my next question to Mr. Kedia is, what differentiates a semiconductor company that is truly sustainability ready from one that is simply compliant? Over to you, Mr. Kedia.
Yeah. Yeah. By the way, I'm calling from Silicon Valley. So it's good to be with everybody. This is not about meeting the minimum requirement. This is not about passing a test. This is not about being compliant around the requirements. This is about making ESG a competitive advantage, making ESG a differentiator. This is a board priority. This is a CEO priority. The semiconductor space, the data center space is very competitive. there is a lot of investment going in. And if anybody is just looking to pass the test, they will not be successful. They will not go very far. Maybe it is a little different if you're talking about low end, if you're talking about, low value components. But when we talk about semiconductor, that is not the case. The other piece I would say is, so what does sustainability ready mean? It means understanding the requirements. It means having sustainability ready strategy as part of the overall strategy, as part of the overall plan, having a well-organized, systematic plan and resourcing and the right team, and having, all of the things we do when we implement an initiative, having the right governance body, having the right team leaders, making sure there is a feedback mechanism. So Vishwas, I think your question is good, but at least in the semiconductor data center space, there is wide recognition that given the importance of energy and water and chemicals and all of the things we have talked about on this panel, it is very much part of the overall strategy. It's not an afterthought. It's not a band-aid.
Yes, Mr. Kedia. I'm literally talking on a tightrope, and I'm flanked by distinguished panelists, Mr. Vivek Mahajan, Guru Sharan Dhillonji, Mr. Varun Bhatia, Pankaj Kedia. And with this, I'm literally sitting in a pile of information to conclude ESG must be embedded from the outset, not treated as an afterthought. And with rising AI investments, strong knowledge creation, renewable energy momentum, and evolving partnerships, India's semiconductor ecosystem is scaling through localization, risk mitigation, and sustainable integration across sectors. So with due permission of my distinguished panelists, I would like to end this very enriching panel discussion titled Sustainable Semiconductor Manufacturing from Fab to Finance. I thank from the bottom of my heart to all the distinguished panelists. And now I hand it over this session to our host, Ms. Vani. Thank you so much and have a nice day.
Thank you, Vishwas.
With this, moving forward with our second panel discussion is on the topic innovation driving green tech. This panel shift focus to the innovation frontier. Our distinguished speakers are panelist number 1, Mr. George Paul, Director, Government Relation and Corporate Strategies, Sahasra Semiconductors. Second, Ms. Nandini B, Vice President, Electronic Council Alliance City Industries Association, Mr. Sudhir Nayak, founder N-Cube Semicon Private Limited, Ms. Chavi Jain, VP LPL Financial USA, Dr. Vijay Wagh, Head Semiconductor and Data Center Projects, Larsen and Turbo. And our moderator for this session is again Mr. Vishwas Das. Let's dive into this forward-looking discussion. Over to you, Mr. Vishwas.
Thank you, Vani. And I can see there's one more minute left in good morning. So good morning to all my distinguished panelists. I'm really enthralled to be here in this panel discussion, which is titled Innovation Driving Green Tech discussion. And the motive of this panel discussion is to discuss about the role of digital technologies, AI, which is everywhere, IoT, data analytics, in accelerating green technology, and how energy tech innovations move from laboratories to large-scale deployments. And we would be talking about bridging innovation, scalability, and commercial viability in green tech. So, with this, I would like to thank each one of you. And with all of your due permission, I would like to begin this very enriching panel discussion. Mr. George, I would like to go ahead with you. My question to you is, from a government relations standpoint, what policy interventions can most effectively accelerate sustainable semiconductor manufacturing in India? Over to you, Mr. George Paul.
Yeah, good morning to Electronic Era. And on behalf of Sahasra Semiconductors, I wish to thank you for inviting us to speak on this summit of yours. Just to give a brief background, Sahasra Semiconductor is a pioneer from the private sector to get into semiconductor IC packaging. We started our journey 3 years back, and about 10 months back, we started our first commercial shipment of made in India chips. And today we ship to over 8 countries across the world. And our project was a bootstrap project where we built it right from greenfield. And in such a complex domain like semiconductors, you see one of the common refrains is that you need to have technology partner who will give you the technology. We were in a position being greenfield, grounds up. From where do we get that stack? So our engineers put our heads together, and then we drew up the entire process chain. And in the process, we worked with the different domain experts. And one of the things that very clearly came out in that journey was this is a product that gets supplied to a global supply chain, and their ESG standards are equally critical. So it's today a done or an accepted fact that these are the minimum stakes on the table, that you need to meet these standards if you want to be viable into the business. It would be very foolish to go into this sector without building in the ESG safeguards that is expected by your customers. Now, policy plays an important role because environment typically falls into what we would classify as good to have, not mandatory. All right, that's normal human nature. And how much do you invest into environment? There is no limit, but you have to draw a line which will balance between how much you invest and what the market is willing to pay. As engineers, you can do a lot, but there is only so much that the market can pay. So government policy plays 3 important roles. One is guidelines, second is an enabling function, and third is a forcing function. And industry and government have to work together in drafting these policy guidelines so that you have a healthy, homogeneous growth that happens.
This is very well said, Mr. George. You basically delve into government policies, and you spoke about the 3 factors related to government policies. So now it brings to Miss Nandini B. And ma'am, for you, my question is about electronic clusters. So I wanted to ask you, how are electronic clusters and industry associations enabling green tech innovation at a scale across the semiconductor and electronics ecosystems? Over to you, ma'am.
Thank you. Sure. Good day to you all. Thanks for inviting me. Small introduction about Electronic City Industries Association. We are called as LCR, and we are in Bangalore. So we are a conglomerate of about 300 companies, and we have micro, small, medium, and large companies like the Infosys, Wipro, Tech Mahindra around us. So there's a very unique ecosystem that we maintain here, where these large companies support the medium and small companies to grow. So it's a very, very unique ecosystem. So in connection to your question, I would like to say that we also have a EMC cluster here maintained by Electronic City Industries Association. And since we are one of the largest clusters and most sought after because of the kind of companies that we have in here, I would like to say that clusters are the fastest way to scale, to scale sustainability. If we do it with one company with green practices, it takes time, but then with clusters, we can industrialize them. And also, clusters enable shared infrastructure, like what we have here in Electronic City. Presently, is that we have common effluent treatment, and then we have water recycling, solar panels, and also e-waste management. These are all put together, and the Industries Association maintains all these things because these are all highly capital intensive, and small companies, it's economically not viable. So when it's shared across the ecosystem, it really works, and that's what's practically happening here in LCR. Second is that we can create some kind of standardization, industry associations, so we can develop sustainability frameworks and also supplier readiness programs, which we do call some experts and train our MSMEs to start adopting them. We get some ESG playbooks that help the MSMEs to align with the global OEM expectations. Because today, for MSMEs to reach out to global OEMs or to get their business, they do not know much about what the global business expects. So we do have programs which educate them and help them to grow. And also clusters, we act as a innovation sandbox, I should say. Whether it's a circular electronics or AI-driven energy optimization or resource-efficient manufacturing, ecosystems allow pilots to scale faster because knowledge spreads quickly. And whenever we meet across every month in our meetings, we share our details with each other. So we're kind of supporting each other well. So associations play a very crucial role to bridge the gap. And also they translate government intent to practical roadmaps. So that's the way we are currently operating. And so I should say that sustainability as such is not only a company level outcome. It is an ecosystem outcome, and that's what LCI is doing currently. And we would like to share our knowledge with the other associations also, if anybody is interested.
Yeah, thank you, ma'am. It's great to know about that you have some common e-waste management and other capital intensive things. And now it brings me to Mr. Sudhir Nayak. And Mr. Nayak, for you, I have a very interesting question. Like, as a deep tech founder, how do you balance innovation, sustainability, and commercial viability in the semiconductor space?
I think all the 3 points what you are bringing up, Vishwas, itself is a chapter by itself. And if I have to summarize, it's going to be like 2 minutes elevator speech. But I will try to do justice. And if I'm overspeeding time limit on particular question, please tell me so. So I will stop it actually. So let me give you some background to the viewers actually. Semiconductor is a very complex industry on the earth. I don't think there is any other industry which is so complex because they scale the cost and it is an atomic level product which we are talking about. We are, as a India, we are doing just first step in manufacturing. We can say we are extremely good or thus when it comes to the design because we have been able to design many chips. But manufacturing, we had absolutely no role to play as a country, except SCL Semiconductor Mohali. We had some modest beginning. I think you all know that we had a AI Impact Summit. Last 2 days, I was in Bangalore. We have IESA Vision Summit. Today, there is Professor Tumal Rao. He is talking on advanced packaging at IIT Gandhinagar. Day after tomorrow, our Prime Minister is inaugurating Micron facility here in Ahmedabad. And first and second, there is a Semiconnect Gujarat happening. And wherever I go, I see always only one thing, semiconductor and AI. These are the 2 buzzwords in the industry. Let us talk about, giving this background, let us talk about the innovation. So when the transistors were first established, the first semiconductor chip was of 4 transistors in 1974. Today we are talking about billions of transistors over there. And all are aware about Moore's law. that every 18 months, number of the transistors will double and the size of the silicon slab will half, cost will come down to almost half actually. Now, if you look at the 2 nanometer transistor, its size is 12 to 15 nanometer. Silicon atom is 0.2 nanometer. So we are 60 atom away from the physical limit of making transistors. Today, if you look at the iPhone, there are 16 billion transistors on iPhone actually. It's reaching the limit of 2 nanometer. The cost, when about the viability it comes, 2 nanometer chip design cost is anywhere between 750 million US dollar to 1 billion US dollar. One fab to manufacture 2 nanometer chip is nowhere less than 45 to 50 billion dollar. No independent company can set up any semiconductor fab. And that is why throughout the world, there are chip law, there are European laws. Everywhere it has to be funded because there is no ROI. If somebody has to put up any fab, I don't think even you will have 10 years ROI on that actually. Even Tata Fab, which is coming up here in Dholera, I am from Ahmedabad. I am just sitting right now in the happening place of semiconductor. It is $10 billion, out of which 50% is given by the ISM and 20 to 25% is given by state election. So only 30% is given, and still there are question marks because they have internal consumption. It is going to happen. The point I was making, that cost and the physical limit of making the chip is going down. So what people came up with innovative idea. One of the idea was that let us take this 300 mm wafer and put 1 trillion transistor on the same things. And people have developed that, it is working and it has become very innovative. Second thing is a chiplet now, that you don't do everything on one device and create issues of noise to signal ratios, power loss. So people are putting, instead of going horizontal, they started now going vertical. So that is one of the major innovation which has happened in the very recent past outside India. We are talking on 28 nanometer, which is why we are doing 28 nanometer. I'm not going there because that is not the scope. But I think that will take care of 40 to 50% of requirement worldwide of this. You don't need 2 nanometer, 7 nanometer, 10 nanometer for all the applications. Majority of the applications which India consume will be taken care of 28 nanometer. So, but chiplet is coming in the process, and that is as far as the design is concerned. 28 nanometer is a well proven, and people are ready to part with the technology. Even if I have $50 billion, if I have to develop the technology to manufacture, it will take decades. So somebody has to part with the technology. So India is right now on the path. I think first fab is coming up in Gujarat, and then there are 2-3 fabs, as we discussed in earlier panel, that silicon carbide and gallium nitride. They are coming up in Vizag and Bombay and other places as well. Soon there are going to be announced more things. But government help, if it is not there, this will not fly. So commercial viability is possible just because government has to help, and they have to do hand holding for quite some time. ISM 2.0 is likely to come maybe somewhere in by April, middle or April end, and that is going to boost, which was not taken care in the first. And I think they are taking care of logistics, which is the most important thing in when you go for semiconductor. And no, in the world there is not a single country or a company they can claim that we will make from silicon to end chip. It is traveling 50,000 kilometers from sand to silicon. When it gets converted, it passes to 70 gates. And so many people are involved into this actually. Even USA will take 10 years. Even if they put $1 trillion, it is not going to happen. So it's a very complex industry. Innovations are happening all around, and viability is happening through government help actually. So I will summarize here, and if time permits, we will take next round. We will talk about it.
Yeah. Maybe we can come to the next round.
Yeah.
And with your permission, I would like to move on to our next panelist, Ms. Chavi Jain. I wanted to bring some global aspect into our panel discussion. Chavi, my question to you is, how are global financial markets currently evaluating green semiconductor and clean tech ventures? Over to you, Ms. Shavi.
Thank you. Thanks, Vishwas. Thanks for inviting me for the panel discussion. Yeah, I'm very excited to see, India innovating so much in this space and like taking the lead now to become the skill factory of the whole world. So, I want to like address this question from two perspectives. One is like what you have asked, that how people are evaluating the new industry, and also from the perspective of the listener, that each individual engineer, how can they think about this? So, in the first answer, I would say that global financial markets increasingly evaluate semiconductor companies on energy efficiency, regulatory compliance, and user impact. So, they want to see whether this particular product has some edge over other product or not, if they can even sell this product in all the countries or not, and whether this is even sustainable solution or not. So from that perspective, semiconductor is the most important space, because the kind of power constraints that the device in itself have, because these are billions of devices deployed in a very small region, especially in India, which is very densely populated country. It matters a lot, because it's not just about efficiency or energy or environment, it is also about human health. So when we like dissipate energy at millimeter wave frequency, it is not just impacting environment, but it directly impacts human health. It can actually burn people's hand who is holding the device. It is that critical. So when I was in Qualcomm, I was actually working specifically in this space where it was low power 5G systems, and I was filing patents after patents on that. So when I was trying to do that, I figured that these are the most important and crucial patents which Qualcomm was actually not filing just in the US, but across the world, because these are the main things that matter to people, whether their phone battery will last longer or not, whether the device that they're using now, the AI devices, their robo will keep working for days or not without charging. So all these are the very important consumer selling points, and they have a sustainable outcome. So from an investor perspective, the reward is not just in terms of, okay, we love environment, but it is actually product competitiveness. And it will at the same time minimize environmental impact and ensure regulatory compliance. So all of these are very valuable, important things that people have to think from the beginning. And when we think about AI, there's another space which is coming up very quietly but very rapidly, is tiny ML. So there are going to be more and more chips which are going to be deployed in the whole like regions which never had seen any electronics before, maybe in forest, to catch when the fire can happen, or to check whether the soil is correct or not and stuff like that. So nobody can go and charge that chip at that level. So those are going to be solar powered chips. And for those chips to be able to sustain, they have to be, power efficient and energy efficient. So this is a very innovative sector where each and every engineer should take interest to basically prolong their career even after AI takes over the coding.
Yeah, Ms. Shavi, your point of human health is totally strikes. It totally struck to me, and you have rightly pointed it out that it should be kept in mind as well. So, with this, I would like to move on to Dr. Vijay Wagh. And Dr. Wagh, my question to you is: semiconductor fabs and data centers are energy-intensive infrastructure projects. How can design innovation significantly improve their energy efficiency and sustainability? Over to you, Dr. Wagh.
Thanks, Vishwas, and thanks all panel members as well as the e-electronics for giving this opportunity. So basically, what you have said, that data centers, mission critical, and semiconductor fab, OSAT, or small OSAT which are coming. Yes, they are very energy they are having very big impact on the energy consumption, and the power requirement is also huge. Like nowadays, what we are listening, that AI data center is coming 100 megawatt, 200 megawatt, 1.5 gigawatt. Likewise, whenever we are talk about the any fab, they are talking about 100 megawatt will be the load capacity and all. So these things, when we design, when we start designing of the data center, or when we start designing of the semiconductor fab or OSAT, we first think about the how the power will be coming from, which network, which grid we are going to connect it. And whenever we are connected to the grids, that should be a sustainable. Again, there is a issue of the stable power, at least in India. So the grid which 400 kV as well as 220 kV, which is available, there is a lots of fluctuations are there. For that, how we are going to control that? So for that, when we design the fab or OSAT or any data center project, we first look into the what kind of measures can be taken. The like for AI data center, AI factory data centers, we are thinking of taking the base as a one more option. And in AI data center, we are trying to put the capacitor banks in front of UPS so that can sustain that spikes, which is going to get increase because of the heavy computing and all. In OSAT and in your fab, whenever there is a MHE machines, they are moving the wafers from one location to another location. The starting current of the each MHE is going to be increased. Although they are having lots of soft starters and all, but still the impact or the spikes which is coming, it's more than 7 to 8 times of the required load. So that should not go to the grid. That is also one of the major aspect we look. When we design the things at that time, we try to like OSAT and fab as well as data center, we create the 3D module of that. We put the visual audio visual creator, and in that we actually put each and every machine as well as all the data center this DC racks we kept, and after that we simulately check their capacity and all the things. And when we go to the energy and these things, we try to use the maximum efficiency, and for improving that efficiency, so PUE and WE is the major part of data center. Whenever any data center developer comes to us, they first ask about their PUE and WE, what you are going to offer. Nowadays people are talking about 1.4 1.3, wherein in US, in Texas, which where I have developed the data center, they are talking about 1.23 1.22. So such kind of big difference is available in India. Apart from that, in OSAT and fab in Taiwan and all, where we are asking about 100 or 120 megawatt, they are operating on 80-85 megawatt. So we are also learning from that. So maximum use of robotics, the PLCs, DDC networks. So these all things coming together, we are trying to decrease the energy from like 14 to 15%, but that is also again a challenge, being the we are importing the machines. When we import the machines, the operators needs to be get skilled, so lots of training and all the things. So whenever we design this entire ecosystem, we understand that we have to be very conservative to selection of the equipments which we are going to select for this data centers and OSAT as well as fab. So such kind of design constraints we try to sort it out. Thanks, Vishwas. Hello.
Thank you so much. Yeah, thank you so much, Dr. Wagh. And with all of your permission, I just wanted to, declare or announce that as a sutradhar of this very enriching panel discussion, I have a very, important responsibility of walking on a tightrope, and I'm already walking on a tightrope. So, with all of your permission, I would like to get one key piece of advice from all of you, and you are kindly requested if you can sum this question or key piece of advice for your industry peers in 1 minute to each one of you. So I would like to begin with uh, Mr. Josh Paul. So what would be your one key piece of advice which can be summed up in 1 minute to all the industry peers? Over to you.
Thank you, Vishwas. Your second question was how do we convert sustainability into a competitive advantage?
Yeah.
And a very good strategy there is what leading with standards. Industry moves on standards, and the industry in India, along with academia, come together and they drop the standards and get them adopted on the global platform, then you are chartering a path where the Indian industry that is associated with you have got a heads up and a lead in implementing those standards, and then those then turn into competitive advantage. And increasingly, we are seeing India recognize the importance of this. A case and example is India's active participation in defining 6G standards, in defining AI standards. On a similar lines, on the sustainability side too, we have this opportunity in front of us to summarize, lead with standards, build it into a competitive advantage.
Thank you so much, Mr. George. And Ms. Nandini, what will be your key piece of advice for the industry peers? Over to you, ma'am. Can you hear me?
Yes, I can. Yeah. So since I represent industry association and I also represent MSME, I want to say that for MSMEs, sustainability should start with the operational efficiency, not only for reporting purposes. So ultimately, sustainability is not a moral choice, and it has become a very competitive strategy today. So with the right ecosystem, green manufacturing can become India's biggest global advantage.
Thank you so much, ma'am. Yeah, thank you so much. And Mr. Sudhir Naik, what will be your key piece of advice for industry peer group?
I think rather than advice, I would just like to add on the main discussion which was there on the innovation and sustainability. There is a major disruption is happening in this industry, and it is taking shape in Surat. We are normally tuned to using silicon wafers, and silicon thermal conductivity is the biggest issue, and that is why all data centers are just drinking energy. If you look at the diamond, I think the thermal conductivity of the diamond is many fold far better than the silicon. With few of my friends, we have come up with the wafer of 4 inch, and if we can go to 6 inch wafer, I think the future in quantum as well as in semiconductor, the silicon will be replaced by diamond, and your energy consumption will come down to 1/10 of what is happening right now. It will help big way in sustainability. We were in Germany Semicon, we were in Japan Semicon, we were in India Semicon. We were the only player who was demonstrating this. The point I'm making, it is not marketing of this, but innovation is nobody's chartered. It cannot happen only in US. It cannot happen only in Japan. But the lab-grown diamond, since it came into existence, what I'm talking is becoming commercially viable. Earlier, diamonds were only held here or necklace or in the bracelet. It was not making economic sense. With the price was 2.5 lakh rupees per carat. This is around 13,000 rupees per carat. And because of this, this is Japanese people are using our material at a great extent. And what I am suggesting is that the newcomers in this industry, if you want to participate in this game, they should think innovations of building IP. We don't have any IP in the country. No chip can be made without IP. Only RIX5 has been made popular a little bit of late in last 1.5 years. Likewise, there are so many IPs which we need. And now with the fab available here, we can do it a silicon proven and build AI agents who can improve the efficiency of entire eco chain from sand to ingot to wafer to chips to packaging. Unless until we go to that route, I think we will be adopting traditional use technology by others. As I made earlier statement that TSMC has given technology because 28 nanometer is now they can part with. Today, if you ask for 2 nanometer technology, nobody is going to give you. Whether we need or not is a different story. But in between, there are good jugaad which we can do it. And I think there is enough space for everyone. If you can go for agentic AI in manufacturing, because we don't know manufacturing yet. I think we'll know in another 2 years time actually. We don't know where to train the people. We have to send them to Taiwan and Korea. Even all these people who have put up the plant, they have trained them there. There's a big avenue for training these people. So my advice is to look for small thing for startup and don't think about, see, these are deep pocket, fab or packaging plant. You will not be able to survive. So find out how you can be tier 3 players and helping them actually. I will live with that.
Thank you. Thank you, Mr. Naik. And Chavi, very brief key piece of advice from you, I would request.
I will conclude, and I actually, support everything that has been said on the panel till now. And going from the IP perspective and, keeping it short, I would just say that whatever we will do will scale to billions of devices. So energy efficiency cannot be afterthought. It has to be built in the product from the very beginning. And also we have to be aware that all these chips will turn into toxic waste at the end of the cycle, but they are actually very valuable rare earth materials. So we have to also bake in energy efficiency and recycling from the very beginning to be sustainable product building a country as India. So with that thought that the impact here every engineer is making is huge, because your work is going throughout the world and it is going to billions of devices. So every single line of thing that you do, it's very, very impactful.
Thank you so much, Chavi. Dr. Wagh, if I may request you for a quick key piece of advice, over to you.
Basically, after discussion, after listening Sudhir, Nandini, Chavi, and George, it will be very little space for me to say on. But yes, definitely the sustainability will increase it will reduce the carbon footprint on entire globe and not only in India. Secondly, the steps taken by the government, which the environmental control certificates and all, which is impact on the project progress, but at the same time, it is also helping and supporting the sustainability goals which entire globe has. So I respect that. And apart from that, this major area where semiconductor and data centers we are proposing into India, or they are becoming a hub of entire world. So as a becoming when we are becoming big, at the same time, this is the major responsibility lies with us, that we have to think about the major impact of on the entire global warming, as well as the things which we are not able to control by using the fast creation of the big hubs of semiconductor and data centers. We have to control, and definitely there is so many things are there which all the team members has discussed upon. But I will just touch on the sustainability issues which are impacting on the projects. So people are thinking that, okay, we can bypass few things and we can go ahead with some other ways to go ahead and all the things. But it is really important, and government is supporting on the other side, the private investors. Last Pankaj Kedia and these people, when they are talking, I was listening properly. That time also I was listening properly and understanding that how these people are think about the projects which they are going to put in, and how they are considering sustainability into their investments also. So it is really good, and hope the best will be entire world will see that. Thanks, Vishwas.
Thank you so much. This topic is so interesting that even a person like me who doesn't have a technology background is so intrigued and glued to all of your deliberations. But keeping the sanctity of time, I would like to conclude this very enriching panel discussion. As we wrap up, let me leave you with this. Sustainability is not optional. It is the entry ticket to this industry. If policy provides the guidelines, enables action, and enforces accountability, are we ready to lead rather than comply? With clusters, shared infrastructure, responsible power choices, and stronger partnerships, India is not just participating in semiconductors. I think we are shaping a sustainable and globally competitive future. So thank you so much to all my distinguished panelists. I look forward to meeting you in person. Thank you so much and have a lovely day ahead.
Thank you, Vishwas.
Thank you
Thanks,
very much.
everyone.
Thank you all,
Thanks
team
for
members.
Thank you all.
thanks everyone. Thanks for allowing us. Bye bye.
As we conclude Semicon Spark Summit 2026, today's discussion have clearly highlighted one message. Sustainability is no longer optional, it is strategic. From policy frameworks and carbon neutral fabs to breakthrough materials and green financing, India stands at a pivotal moment in its semiconductor journey. On behalf of Electronics Era, I thank all our speakers, our gold sponsor, ST Microelectronics, supporting partners, India Energy Storage Alliance, Electronic City Industry Association, Global Electronics Association, and National Highways for Electric Vehicles, Urja Daily, and our audience for making this summit a grand success, insightful and impactful. We look forward to continuing this dialogue and building a greener, smarter semiconductor ecosystem together. Thank you and have a wonderful day ahead.